Hey everyone, welcome back to the Science versus Pseudoscience mini-series. We've had two conversations so far on issues on delineating the difference between science versus pseudoscience, whether or not it's useful. And now I fear that it's time to start bringing in some more specifically statistics and data science conversation on these issues. So of course, we have Deborah Mayo here to lead the way. So thank you for helping us bravely venture into the unknown here. I wanted to just sort of, as you know from our conversations before, prior to recording, we've gone off into some interesting routes with this conversation. But yeah, I figured that we could just sort of start having a conversation first, starting about, your own thoughts on the delineation of science versus pseudoscience, and then we can just see where the conversation takes us. So, Deborah, welcome. Maybe just to begin, one of the main things one of the ideas that's gone by is sort of there's been this Potter-Stewart idea that we'll know science versus pseudoscience when we see it. And that the issue of, finding necessary and sufficient criteria is not worthwhile. And I'm just, obviously, since you're here, does your general view on these things differ significantly from that view? And if it does, in what ways?
Well, thank you very much for inviting me. Pleased to be here. I would agree that trying to find necessary and sufficient conditions for science and for the vast majority of other interesting philosophical concepts would be a waste of time. But the idea that I can just judge if you have good science when I see it is a big mistake. You'd be surprised at how many methods might look to be good science dressed up as science, and actually they fail what I would consider a minimal requirement for evidence, and that is that you don't claim to have evidence for something if you have done little, if anything, to probe whether the claim is false. So that's my answer to that. Do you want me to say more about it? Because I can. I mean, I realize that was a view under the logical positivists, which I consider a now discredited view of how to do philosophy of science. Many of us want a philosophy of science that's relevant to practice. And in that case, trying to come up with these necessary and sufficient conditions for science, for knowledge, for warranted inference or something, isn't the way to go.
Cool. And I guess just so with that, what would you say is a good definition for pseudoscience? Or alternatively, what you can also go, what's the definition of the good practice of science? But maybe just what's a good definition of pseudoscience, you'd say?
Sure. Of course, it comes along with a full-blown philosophy. I just mentioned about what would preclude good science, and that is when you don't have good evidence, and that is if you have an account where you claim to have warranted grounds for a claim, even though you've done nothing at all to rule out how that claim might be false. So the first requirement is that you would block those kinds of inferences, and that you want to have methods that are good at probing errors. I think the most fruitful way to approach the question is not to talk about the scientific status of a domain as a whole, but the scientific status of an inquiry. In science, we're interested in finding things out, most often with empirical data plus theory. And so that's my first requirement. But my second requirement is that in order for it to be a scientific inquiry, not only must it block claims that haven't been probed at all, but it must be able to come up with a probe, or at least embark on a reliable probe for pinpointing the sources of any misfits or anomalies or failed predictions, whether it regards models, claims, estimates, or something else. Those are the two things. And pinpointing the source of anomalies and misfits, of course, has been a very difficult problem, often referred to as Duhem's problem, because when we make interesting inferences, they usually have a lot of auxiliary background theories. But I'm saying that unless you can at least embark on an inquiry to pinpoint those sources of those misfits and failed predictions, then it's not a scientific inquiry. Those are my two requirements to put it into a very short synopsis.
Yeah, that's cool. I like those 2 points. Just to sort of spend a little bit more time on that second point. I like the idea that when you have let's first do the first point where it is useful, or it might not be helpful to say like, oh, this field or this subject or this community is not scientific. It helps to essentially say like this method of inquiry is not one that will help us generate like well substantiated claims and will not help us work through the faults in an unsubstantiated theory, or will not help us actually work through when a theory or an investigational method does not actually align with what evidence we have. For the second point, though, can we spend a little bit more time on that about pinpointing where, for example, your theory and evidence might not align, or your theory might not align with all evidence?
Yes, I mean, if you have an account where you can always hang on to a theory or model no matter what, then I'm saying that that's being unscientific, or that's veering into the unscientific. So even if a claim is logically falsifiable, if you have enough protective face-saving devices, ad hoc maneuvers, cherry picking, changing the hypothesis afterwards, that kind of thing, then even though a claim is logically falsifiable, it's not actually falsifiable by your inquiry method. And so that's how you can fail that. On the other hand, it's not always easy to be able to pinpoint the source of some anomaly. And I'm saying that's a necessary requirement, or at least that you're able to embark on an inquiry in order to pinpoint blame. And along with that is the idea that if a claim is falsified, you don't continue to hang on with it no matter what, that the claim is treated as refuted for further work, although even falsifications are, strictly speaking, provisional, and things could change where it comes back into the game, and you would need to explain how that happens. Further, though it's not an absolute requirement, you should be building theories based on whatever has been well corroborated, whatever you have put through a stringent ringer. That is, the science makes progress, and it's not just stamp collecting of a bunch of disjointed claims.
Yeah. On that issue, just so that I guess people don't misinterpret. One thing is that I was thinking that like when we talk about these claims, are these like particularly fragile claims? So the idea is like how much is needed essentially to effectively falsify something? Is it simply error or deviation away from a prediction, or so? What is your feeling on that?
No, it wouldn't be enough to have an observed disagreement. What you would want to do is, as I say, find the source of it. And even if you find one and you generally say, my theory is broken down, or it appears to break down, that's not enough. Single, isolated disagreements, as Fisher would say, isn't enough. We need to be able to reliably bring about these misfits and understand their sources, really, to have a full-blown reputation. And this, of course, will connect to when we talk about statistics, since that's one of the main things that it tries to help us achieve, at least in those areas where we deal with probabilistic models. Does that answer what you were after at that point?
Yes, yeah, that was definitely helpful. Because I guess one thing is that I don't want people who are just sort of tuning in to things like, oh, when we talk about the idea of some theory or some method of inquiry being falsified, that essentially means that you can get, one-off falsified by some effectively trivial circumstance. That there's something more grounded to it than that.
Yeah, don't forget, let me qualify that. This requirement of mine about severely testing works here too, right? So in order to affirm something as false, okay, is to corroborate it. And so you would have to show that you have done something that would not have found it false, okay, were it in fact correct or approximately correct. So that same requirement for good evidence holds when the inference you're making is that's false, that drug doesn't help, or something like that. You have to show that you have put it through its steps, and with high probability, you would not have come to that conclusion if it were false.
Yeah, I really do like the idea of severe testing, just like as a framework, even just for personally checking my own work, where I just say like, okay, has this if the and I'm going to botch this because I wasn't quite prepared to talk about this, but the idea is like, okay, if is my claim has a sufficient amount been done such that if my claim were false, we would be able to identify those fallacies or those points of conflict. And so yeah, I definitely do like that. To skip over just sort of one thing that obviously that I've been thinking about since the previous interview that I had last week was this idea of Thomas Kuhn. And it was brought up the idea that effectively Kuhn's work sort of formed a bridge on which people were able to storm into science and take it off its pedestal. And I was sort of wanting your opinions on that. And I'd always thought that a little bit, one of my sort of disagreements with that is that, there's that, I guess it's an Aesop's fable thing where it says, a tyrant will always find a pretext for his tyranny. And so my thought was that when people are wanting to take scientific inquiry and some of these like rigorous critical thought off its pedestal, that probably a community that might do that might sort of want to do that anyway, and they would not have needed Thomas Kuhn to begin with. But at the same time, I was curious about what your thoughts are, one, on the idea of science being taken off its pedestal by Thomas Kuhn, and more importantly, since I wanted you here to talk about statistics, has statistics experienced that effect?
Yeah, I mean, it's kind of complicated. I'm unsure whether you're saying that this individual said when Tom Kuhn came along, he really showed us that we can't characterize good and bad science, and gave people an excuse to say there really isn't anything special about science. Is that
it was more on the idea that his work, whether intentionally or not, essentially gave people outside of the scientific community chance to say, well, look, science is just another social phenomena. It doesn't have any, sort of privileged qualities in any way. It doesn't have any exceptional qualities. It's simply another social phenomena like the study of history or literature or something like that. And there's nothing special about science, and therefore we should just take it as any other social phenomena.
Okay, well, I don't really think that was Kuhn's view, although I do agree that Kuhn did give some ammunition for questioning certain credentials that we used to hold as indicating science. And I will also say that coming up with a kind of criteria for what counts as good and bad science isn't easy, especially in the face of these kinds of challenges where many people think it's a lost cause. Some would pinpoint Larry Loudon's challenging this, but that goes back to Popper, who thought that we were going to characterize theories as scientific or not, according to whether they were testable or falsifiable. And that's a problematic stance. It's both too weak and too strong. I mean, it's too weak because any falsified claim would automatically be science by that criteria. And it's too strong because in many cases, people say, well, you can't really logically falsify a theory because there are always face-saving devices, the sort of background ad hoc maneuvers that I'm saying a good science shouldn't permit. I think it's a mistake to suppose that this is a lost cause and that it's quite important for philosophers to be able to say something about good and bad science understood as in terms of the inquiry, better or worse. And it's not a matter of a strict cutoff, but neither is the severity assessment a strict cutoff. It's quantitative. So here's where Kuhn comes in because he thinks that he's really following Popper. And he's saying, I agree with Popper. It's just things come out sort of topsy-turvy because for me, Kuhn, I think that good science is all about science within a paradigm. And this classic Kuhnian paradigm idea is that the paradigm gives you methods and theories and also values all together. And it gives you puzzles, as he called them, to solve and never rock the boat of the entire theory, according to this Kuhnian idea. When you are having a crisis because on and again you're getting these misfits and failed predictions, then the whole field goes into something that is non-science, and eventually a revolution might overthrow that theory. But when you're really doing science, according to Kuhn, you are within that paradigm. This whole challenge, though, as to whether you can solve those Duhemian problems, in other words, the whole challenge to whether you can satisfy my second requirement comes to the fore, not just with Kuhn, but with many people who are challenging the positivists and bringing out theory-laden data, that you don't just have pure data, that there are always these background theories. And so there's always this issue as to what is at fault, okay? And so Kuhn did give people this idea that that couldn't be solved. And therefore, it was just all a matter of what the paradigm told you. And what were the good rules in that paradigm? Well, it was just whatever was made up by the particular social group. He didn't really see the normative components of his own philosophy. So he would say, what's scientific? It's whatever the scientists do. So I think that he really shortchanged himself. And after Kuhn, there were a lot of people who developed much more radical relativistic views, Dadaism and postmodernism, and knowledge as a social construct and all that. And so I think that's where this idea that Kuhn gave people a handle on denying there's anything special about science comes in. And there's no doubt that we have people like Diederik Stapel and certain frauds who say that they learned their radical constructivism from Kuhn or something like that. They learned their anarchism. Feyerabend was also an anarchist, but he wouldn't have gone as far as Diederik Stapel, who said there's no point in even collecting data, which he didn't bother to do.
Yeah, so I guess 'cause Kuhn actually sort of replied to this more radical reaction to his work. Because my understanding is that effectively he wrote a hey, wait a minute, stop science type of piece that followed up on it, saying like this was not sort of essentially trying to re-clarify where he thought sort of a more reasonable bound to his conclusions were. Is that
right?
correct?
And that's why I sent you that paper, and it's also the second chapter of My Era in the Growth of Experimental Knowledge. He did write this response saying, Popper had said normal science is dangerous. It's science by somebody who has been badly taught. And he said, of course, I didn't mean that. And he had many requirements for good science within a paradigm. But in the end, I think he couldn't help but say, go back to his more radical view. I've always thought it was because that was his claim to fame, and why give it up? So in the end, even when he was coming back and giving us very careful normative ideas about what it is that a paradigm does for us to really constrain our solutions and make sure that they're rigorous. And then he'd say, but when the whole theory is in question, he would think that everything is questioned at once, the theories, the methods, the values. Where do you stand where you're doing that? And he'd say scientists aren't trained to do that. When they're doing this abnormal or revolutionary science, they're more like philosophers or metaphysicians, and they have to make use of criteria, things like simplicity and unification and so on. Um, but of course, this idea of Kuhnian normal science really doesn't happen. And there's little, I would say, no evidence that one is ever in that circumstance. And in fact, Kuhn's own idea about what normal science is all about really conflicts with that, because normal science gives you those low level, those local methods for holding claims accountable and for reliably probing errors and so on. That doesn't go away just because you're challenging the fundamentals, be it relativity theory or something else. So I think he was just wrong with his revolutionary view. He was reluctant to give it up, though, despite those disclaimers.
Could you just for people who are coming in, we don't need to go into it in too much detail, but the idea of normal science, because some of the way that I've heard people summarize Kuhn was that normal science is effectively the day-to-day operations of good, diligent, hardworking scientists as they work to further build on incremental aspects of a greater theory. So, for example, in lab sciences, that we have this idea that their cellular mechanisms are biological mechanisms, and they work in a certain way. And what normal science does is it actually helps us better quantify, better understand, in greater granularity what a greater theory is saying. And that the idea of the revolution that comes around is essentially when too much, when scientific revolution comes around, that effectively too many details, too many conflicts arise, and it creates this crisis by which then we need some radical reformation of what the grander theory is, perhaps even throwing it out. And essentially then it becomes a philosophical issue. That summary is that it seems to leave certain things out, though, because I think that's sort of like that day-to-day practice of science, which I consider myself part of. It isn't quite what Kuhn's description encompasses. Can you sort of give just a little bit more on sort of what the practice of normal science might be?
I think if you go through those details, it pretty much covers sort of anything that you would be doing. He could call it a puzzle, right? It gives you the tools to focus on a very local puzzle. It gives you the psychological and sort of moral standpoint from which you can unearth things in an extraordinary depth. You've got your theories and you don't question those. You've got your methods. You determine whether it's a statistical method or measurement and so on, and you don't question those. And there are certain styles of explanation, and there are values along with the thing that we care about. And those things change in history. That's the other thing that people attribute to Kuhn, that there's not going to be this one set of goals for all time, that at one point they wanted more prediction of local effects. Another time they were interested in deep explanations. This whole idea that even the values and goals could be historically relative, okay, was really strictly Kuhn. So, he had a list of things that you would do in normal science. Connect your own research project with the larger one, determine scientific fact, estimating magnitudes, things like that, and then pretty much covered everything that you would be doing in science. The only thing you wouldn't do is challenge the deep underlying theory. And this is what Popper thought was very dangerous.
Oh, yeah, that's really helpful. And just to get one more idea, so what is the magnitude of change that would be needed for Kuhn to have classified something as a scientific revolution? Are we talking essentially some like the major landmarks in physics for revolution, or is something are more mundane aspects sort of permissible as a revolution?
Well, for him, it would have to be something major. And remember, I said that I think the whole conception of Kuhnian revolution really doesn't bear out in actual science. But the sort of thing he had in mind would be large scale theory change. And after Kuhn, people got into this largism, we might call it, after Popper and Lakatos. And it's linked to this concern about being able to pinpoint blame for anomalies, because people started to say you really cannot pinpoint blame for anomalies. There's background theories. You can always make an excuse, an ad hoc save. They said what you want to do is not pinpoint the cause of the misfit, as I say, is a requirement. They say what you want to do is choose the best package, choose the best overall paradigm that you like, because you can tamper with something in the theory. We usually consider that the hardcore. We don't tamper with that right away. You can change your measurement definitions. You could change your goals. It's a whole lot of things to do. Choose the package you like. and that's what they regarded as revolutionary science, changing the package. And it was more of, he would say, it's a gestalt switch. It doesn't happen one step at a time. It happens all at once. You suddenly see the light and you're seeing the world relativistically, let's say, instead of Newton-wise. I say that doesn't happen. And insofar as it does, it's really irrelevant to science.
Cool. And I guess just the second part of this greater question is like, has any of this philosophy worked its way and had effects on the statistical community, statistical developments, and things like that? Are we sufficiently peripheral to some of these bigger arguments that we haven't been affected, or it seems more like, obviously no one's immune to these types of trends? And how is Kuhn affected or not affected, sort of the direction of the philosophy around statistics?
I'm not sure. I do think that everybody has heard about the theory-laden business, and our models are always false and so on. And it's not just Kuhn, of course, and that therefore we don't even have to test them because we already know they're false and things like that. And that we're reduced to talking about what's useful. But I don't think that he comes up so much. I think Popper does to a large extent. So maybe, I don't know, maybe when we do talk about statistics, that will come up more naturally, what you have in mind.
Yeah, should we just hop over to that conversation now and just start doing some stats?
Okay.
Cool. How would you like to begin that?
Well, I would say that statistical methods are very important in distinguishing good and bad scientific inquiry, as I understand it, because methods of statistics, first of all, arise primarily when we're dealing with effects where the errors aren't totally swamped by noise, so that you actually it's hopeless to even come up with something. On the other hand, it shouldn't be that the errors are so clear-cut that you didn't need statistics. You just open your eyes. It's somewhere in between. And a natural view of the role.
As a quick interjection to that, I really like that distinction that you made, because I think that this is, I'm going to interject because obviously I think that some people listening, might benefit from this, that in things, this is not some esoteric point. I think this is actually extremely useful for people who are wanting to practice statistics and data science, because effectively there are, on these opposite sides, if something is so noise ridden, and noise isn't just, this has a high sigma for something like that. There's a severe amount of fundamental noise in the data generation process, or there are a sufficient number of unidentified and irreducible confounders in your data set that you don't have a way to pick apart. there's one side, and that's something that people need to be very aware of. The other side, though, is that there are legitimately like nearly mechanistic phenomena going on in some of the data that we have. And so effectively, when you're dealing with some of that mechanistic, those sort of mechanistic processes, a lot of traditional statistical and data science techniques are not only unnecessary, but they're actually like extremely inappropriate because there are simply better ways to sort of be handling data of that nature. And in fact, some of my biggest problems have been from the mechanistic side, where essentially zero noise scenarios for which statistical methods are not actually very useful. And so I wanted to just quickly interject that that is a very useful thing to note for people who are actually doing the practice of data analysis. And now
yeah. What's an example, though, of one of these mechanistic things where statistics doesn't enter? I'm just curious.
Yeah. So I think that surprisingly, well, as you might know, the field of data science, I think a lot of the interest in it has come around from people having digital interfaces and things that create these vast amounts of data. And so you can consider it computer generated data, but I think there's more to it than that. But one such example might be there are a lot of mechanical, basically, processes where we have essentially a very low noise or a zero noise scenario that can create very high volatilities and change. So you can imagine sort of what would traditionally be considered like a stochastic process. So we have some process that's changing in time. And traditional statistical methods are quite useful because there's variance in that process. Typically, there are not discretized, like rapid changes in it. So essentially, there's continuity in the state, for example, in the state that you're trying to model. And for a lot of these, sort of like electronically generated data cases, that the issue of like whether we have noise corruption is gone because there's no noise corruption. The data is exactly what it says it is. But also that we have discontinuity. So we don't have nice things like exponentially weighted decorrelation between observational points and things like that. So effectively, a lot of things that we've built into our models, like for example, Gaussian processes where you have these different types of decorrelation over time, those don't apply to those scenarios. And effectively, one, we can build models further, we can further complicate our statistical models in order to incorporate change points like that. Or alternatively, we can just acknowledge that we don't actually need a statistical model to cover that to begin with, that essentially the data is telling us what is going on. So that's
I'm not familiar with that, but you still have uncertainty and errors, right? In that?
No. So and these would be actually, and that's sort of the challenge because when there is uncertainty and errors, then for example, the sort of like step changes are rapid. So there's one thing where like observations rapidly decorrelate or they remain correlated. And I'd say that's on one end of but I guess it's more like a middle of a spectrum. But there's some where there's simply the correlation simply ends. So it's more like it's just the correlation disappears where one set of part of the data is simply not correlated from another. And I'm moving my hands as if it's like a stochastic process type thing. And of course, there are models that essentially incorporate those things where it just says data in this section of the predictive space is completely uncorrelated to data from this section. And that's cool when there still is actual measurement noise, but there's plenty of scenarios, for example, again, with these electronic records and things like that, where there's not even measurement noise in them. It's a computational system, so it doesn't actually have errors. Of course, there are ones computational systems that do, but yeah.
Okay. My thinking is that statistics gives us a general form of reasoning that's applicable even in those cases where you don't strictly have to apply the statistical methods themselves. You're still doing something very analogous, that we're still trying to rule out errors and probe for errors, even if we have a successful system, day-to-day reasoning, my weight gain and maybe a couple of scales will be enough to determine that reliably, and I don't need to do any fancy statistics, but I'm still following the same reasoning pattern. But in statistics, a fundamental job is to be able to ascertain if we're dealing with some real phenomena, some genuine difference, as opposed to the kinds of variability that we expect to see just from background noise alone. Okay. And a fundamental tool in statistics for figuring out whether we even have something to explain is the statistical significance test. And we know that these days, especially, it's very easy to use high-powered methods to identify impressive-looking effects, even though they're spurious. And some people have actually blamed the statistical significance test for making it too easy to come up with impressive-looking findings that later on disappear when independent groups try to replicate them. And they try to replicate them using methods that pre-designate the hypothesis, don't allow wiggle room, and guess what? They don't replicate. But what this shows to me is that the problem isn't the significance test or the p-value, but all of those biasing selection effects, all of the wiggle room, all of the kind of research or flexibility that leads people to try to go for predesignation. Okay. And the reasoning, of course, with significance tests follows this pattern of insisting on some kind of severe error probe. So it might be that we're looking for a hypothesis regarding the benefits of a treatment for COVID. And we look often at randomized controlled trials. The thing is, we expect variability in the benefits, even if in fact the treatment has no effect at all. So whenever we observe a difference between the data and some hypothesis, either about no effect or some effect, we need to see how readily that observed effect could occur by the background variability alone. And so we talk about the observed significance level or the p-value. That's the probability of getting an even bigger difference than you got by background variability alone. And if that's fairly high, that means it's easy to generate what you observed or even something bigger by ordinary variability. So you don't yet have evidence of a genuine effect. On the other hand, if the p-value is very small, it indicates that with high probability, if you're dealing with a universe where there's no real effect, with high probability, you should have gotten a smaller difference than you did. So when you don't, when in fact you get something bigger, we say that that's evidence of a genuine effect. I like to see this in terms of this Popperian testing that the null hypothesis of no effect with high probability would have survived the test if it's true. And so when the test yields a result that's discordant with the null hypothesis, it at least gives an indication of the denial of the null. It gives evidence for some genuine discrepancy. A single test is never enough. We need to be able to bring about these statistically significant effects reliably before we can say we have evidence of a genuine phenomena. Should you want to jump in?
Oh, I was just sitting back and enjoying that, and I was enjoying that bit. Where would you like to go from there? Because
I didn't want to go on and on, but I was going to say, there's a natural set of implications for what we want our statistical methods to do that follows upon this view of good inquiry. For starters, it's going to have to be able to assess and control the error probabilities. That is, the probability that the method would erroneously infer claims. Okay. I say that the other thing is it's got to be able to block inferences that violate this minimal requirement for evidence where nothing has been done. It should be able to falsify claims. And it's very important that it have the apparatus to test its own assumptions. Okay, if your method starts by assuming all of the model assumptions and has no wherewithal to check them, then it wouldn't satisfy this level of criticism. And finally, perhaps even most importantly, that your statistical method should be directly affected by various biasing selection effects, cherry picking, ad hoc moves, changing the hypothesis, p-hacking, and so on, insofar as they alter the method's capability of unearthing mistakes. So we get this parallel. All of the issues about good inquiry have their parallels in what counts as good statistical method for purposes of finding things out.
Yeah. Would you mind talking a little bit more about, because I like to sort of expand my realm of examples on the issue of, for example, sort of statistical methods that entail their assumptions. And you brought up that is it the Pody or Potty example, where essentially a method was developed such that only data that for which the method was developed tests the method, and obviously that's an extreme case. But I was just wondering, could we talk a little bit about that more and how it sort of relates to this greater issue of
Right.
yeah.
Well, so that was this case of Potty using methods incorrectly. Anytime a data point didn't fit his claim about the effectiveness of his personalized medicine treatment, he would just discard the data point. And by that method, the probability of finding an excellent or perfect fit with his pet theory was guaranteed, even though that theory was false. So that would be minimal severity, right? But of course, if you do that and say, "Look, this is the way I define a good check of my account," then you could say that anybody who didn't manage to get the fit is just misusing your method. I mean, this is the sort of thing that could, strictly speaking, happen if you were a kind of relativistic Kuhnian that said, "Well, I define my own measurement methods. There are no universal standards." And if Poddy's method is that if it fits what Poddy and Nevins had as their theory, you keep it, otherwise you throw out the data. And anybody who comes along and says, we can't replicate that as they did, it's not using the right method. That, of course, would be to throw out any kind of learning, any kind of science, any kind of identifying errors. And unfortunately, patients were treated with some of these methods based on that kind of inference.
Yeah, the audacity of doing that. Well, I had two reactions. One, it's like, how would you even think of using that as a way to justify your own work? And then the immediate second thought I had was like, oh man, I wish it was that easy. Because basically, so much of the work, for example, that I do, which has this heavily automated effect to it, where I'm not in tinkering on a minute by minute basis with the inference that my data analyses are doing and what the models are doing. And so I've put so much time, for example, into pre-checking the data that is going into my algorithms and making sure it's like, oh, does this look like a case where my algorithm even would be would have a useful predictive capability? And so basically, there's a lot of what I'd say is in people trying to be better about this. That there's a lot of work that goes into saying, okay, do these data in advance, before we've even seen the prediction, look like data that would actually be usefully, that my algorithm would have some useful say on? And it's like, and we'll flag data that doesn't meet that criterion, and we can let somebody else sort of examine it on a more manual basis, and then whatever does meet that criterion or several criteria, because obviously usually it's dozens of criteria, then goes on and has the predictive algorithm do its thing. And obviously a lot of work goes into that. I like plenty of gray hairs, lost sleep to create the robust systems that are needed to do that. And then for someone to basically just say, oh yeah, we'll just let it pop out on the other end, and then whatever comes out wrong after you've checked it, well, that's the thing that we're going to discard. So that seemed to me, I was simultaneously like amazed by the audacity of that, and then also thinking it's like that's how much work goes into not create systems like that.
It's a classic example. What he did is a classic example of a non-scientific method. And if you can't rule that out, then you really have no business saying that you're clarifying science at all. But still, there are a lot of times where it isn't so obvious. And even his case wasn't so obvious. I mean, he didn't think it was that obvious. And it went through a certain committee at Duke, and they said he can go back. He can go back to what he was doing, even though they examined this, and even though there was a whistleblower who pointed out what he was doing, kicking out the data that didn't fit. It's not always so obvious, and it's certainly not obvious with some of the methods that are being put forward as rivals to statistical significance tests, because they might permit you to find your hypothesis in the data, to data dredge, sometimes called, and claim to have perfectly good evidence. And the issue is always, what's the probability you would have found such a great fit with your data, even though it's false? And it's very high, if not one, sometimes it's guaranteed. And so that, is a really very crucial requirement for good statistical method, in my view. Let it not do that.
Yeah. Where would you like to go from there? Because obviously, we can go in a few different places. One of the issues that I want to discuss, if you want, is there anything more that you wanted to cover on that topic?
Well, I'm not sure what you mean by a different topic. So I guess anything that I think should come up, I'll find a way to eke in.
Sounds good. Yeah, cool. Yeah, one of the other topics I want to talk about was, the issue of the question of science versus pseudoscience, and whether or not that the terminology pseudoscience serves a useful function, or does it serve a useful function in some objective sense, versus in practice, is it more used for essentially an emotive weapon, if you will, to essentially help protect entrenched views and things like that? Because one of the things that you've made a good point about is that, they might not call it pseudoscience. They might just call it bad science, for example. And so that there are some usage of these terms that are not actually meant to help improve science, but essentially to improve entrenched or institutionalized views on certain scientific methodologies.
Yeah, I have to admit that it's true that people don't use pseudoscience as much as bad science or questionable research practices or something like that. And actually, where the real worry these days comes in is precisely in these questionable research practices. People use junk science for a while, but so I don't know if pseudoscience, comes up so much, but we really can cause a lot of the same problems with these questionable research practices. And if you have a method that does not control and assess the error probabilities, it's very easy to adhere to your pet theory no matter what in the same way. So it's just that we don't happen to use that word as much. Certain moves like going straight from statistical significance to substantive significance can result in very unreliable science. But I also think it's a mistake to claim that we shouldn't use methods just because they can be abused in this way. For example, recently some people said, let's not even use p-values, let's not even use significance tests, or let's not even use the word significance, because some people say it automatically means scientific importance, and let's not have a threshold for significance because people tend to do anything that they can in order to reach that threshold. So I think that's a big mistake. All of that. I think that it's a bad argument to argue against a method because it can be abused, that you shouldn't use it. Instead, you should use it correctly. And the most worrisome thing is replacing methods with those that don't have those constraints on error probing capacities, ones that don't even assess error probabilities and allow multiple testing and post-data changing hypothesis and all of that without any penalty.
Yeah, when you said it, it reminds me a bit of the quote. I'm not sure how well known this goes, but the idea is like, if we don't provide people with good, sound, principled methods, they're just going to invent dubious ones on their own. And from the person who was talking to me about that was talking about the need for good, sound, probabilistic understanding of certain phenomena and how to model those. But it did bring about, it does bring about this issue where simply realizing that a method can be weaponized is not sufficient. Well, is not sufficient to discard it, and especially because there's nothing special. A method's ability to be weaponized might not actually mean anything special about that method, because, frankly, probably most or all methods could be weaponized in some way to carry out the task of bad science or to misdirect inference in some way.
Well, I say that some of these methods that supposedly are abused or weaponized actually contain the seeds for just the criticism we want. For example, when we find lack of replication and the whole replication crisis, that's appropriate. If somebody has data dredged, tried and tried again, and exploited various points of research or flexibility in order to get their small p-value, the significance test does just what it should. It gives you a hard time when you try to replicate it, or an independent group tries to replicate it, insisting on pinning down the hypothesis in advance using pre-registration or something like that. That's exactly what it ought to do. And I'm not saying that every failed replication is an example of some kind of abuse, but if you have abused, it will catch up to you. Whereas there are other methods that don't control error probabilities, and you can do multiple testing, keep trying and trying again, have optional stopping, keep collecting data until you find something that fits your favorite theory. It's just like with potty. Then it won't be revealed to you. And that's another reason that I'd say this idea, I know it when you see it, is really inadequate, because you won't know it when you see it. It will look dressed up as if it's very good science. It will be maybe in terms of one degree of posterior belief or comparative Bayes factor. And what you really need to figure out is, where did they get those numbers? And it won't be sort of part and parcel of the account to have this calibration or this error control. You might be able to add it to the account, but it's not already intrinsic. That's the danger.
Yeah. One of the something else similar to this is the idea of incentives, and the idea that effectively scientific community is not free. We're human beings. We are not free of incentives, and that those incentives can have a strong effect on one. Well, I think the incentives have an effect on the outcome that we desire, and then the methods that we might need to achieve those outcomes might fall out from essentially the outcomes we desire, which is a bit obviously of a reverse of the idea of how we should be developing these methods. Did you want to talk at all about sort of the various incentives that might sort of help lead people astray when they select a method?
Disincentives or?
Yeah, incentives or disincentives. Things that might incentivize less things that might incentivize for science.
Well, okay. So, how do we get people to do better methods and not to use some of these questionable research practices?
Yeah, that would be fun.
Yeah, because of course this is a topic of study in its own right. But one of the real risks is that people who are leading in this field of meta-science, as it's sometimes called, also have their own pet methods. And often they're more interested in trying to use whatever crisis is found in the lack of replication to get their favorite methods accepted without having to show that those methods actually achieve the goals of some of the methods they want to replace, such as with statistical significance tests. So what's really weird is that some of these threats come from within science, and it might be a conflict of interest because you have this pet method that you want people to adopt. And of course, now we have more politicization of science than ever in determining all kinds of things in relation to COVID, masks and drugs and ventilators. And it's all a mixture of your values, this is kind of like a Kuhnian assessment. But you ought to be able to distinguish those for good science. It's just that people aren't doing that very often. Do you find that to be the case?
Yeah, I think that one of the things that rang out most was when you said that some of the greatest threats to science, and probably the greatest threats to science, are from within the scientific community. And the reason I believe that is, while I fully recognize that there are external factors that can try to dissuade people from either sharing sound scientific beliefs, or that people might have, second order considerations in whether or not they want to share them. So, for example, they might be less willing to share data that goes against their grander hypothesis. So, I think that there are those effects, and those I would consider to be outside. But back to the issue about whether or not there are some actual legitimate challenges to science from within the scientific community, I think that those are more profound, because the fact is they are more subtle. There is more of, I believe, a direct detrimental effect to scientific careers if you are shaking the tree from within versus, if you are define people external to the scientific community. So, for example, if you are running afoul of if your findings or your methodology or even your complaints about things that are misdirecting scientific endeavors, if your complaints are attacking institutional inferences or institutional interests within science, for example, that is going to be a much more profound issue. And there's much more, for example, of a career risk to be challenging those things. And so
the whole career risk thing is really very important. And that's why I think that in certain areas, especially in statistics, there's an obligation of people who are in power not to exploit that power. This may be an unpopular view, but I think, for example, editors in statistics journals have a special obligation to make sure that they're not sort of foisting their own views and connecting various rewards and awards with people who agree with them on some controversial issues. I mean, statistics has been highly controversial. Bayes frequentist is just one of the big areas for many years. And if you have people at the helm saying, well, we're going to favor a particular account, the likelihood is called maybe a Bayesian or whatever, people are going to be very susceptible to that. We have a very susceptible group to begin with. After all, we're talking about an area where it is thought that lack of replication comes because people are encouraged by the reward structure to publish and to maybe cheat in little small ways that they think won't be too harmful because otherwise they can't survive. If you have a group like that that's already very susceptible, then if people in power try to foist a certain view on them, they're going to accept it. This is a kind of appeal to fear. And I find that really worrisome. And also, if the people in power are using arguments like, since that method can be abused, reject it. If they're using bad arguments, it encourages people to use bad methods because we see that everybody's just, you rub my back, I rub yours. And so we see them inculcating the bad habits. I worry that there are cases also of, journal editors who do this, and I say that it's an obligation that they recognize that there are different views, and that they quite deliberately bend over backwards, not to bias the research that gets published in their journal. And so this would be a big plus.
Yeah.
But
Yeah, on just to follow up on some of those notes, because I might even hold a stronger view than yours on that one. Or maybe it's about the same. We just would describe it in different ways.
Well, I'm relieved. I'm relieved you say that. I thought maybe I went too far.
No. So maybe I'll back up a little bit, and then we'll end up back at that same point where, look, I work with plenty of editors. I do know I've actually even recently been added to an editorial board for a journal. And while, of course, I don't think that we really need to preface too much of ourselves by saying I think that a lot of editors are simply well-intended people who would like to advance their career. But the fact is, a lot of publication work does start to become sort of inbred and in-focused. It can be sort of sensationalized, where they start basically expecting the exact same types of paper and methods and have the same types of conclusions. I'd say, for example, medical machine learning, clinical informatics, medical data science, for example. It seems like the literature has essentially been hijacked by this need to always have this battle of the algorithms approach, where the purpose of any medical machine learning paper must be to compare two algorithms, and that nothing outside of that very narrow, and I'd say, frankly, uninteresting in many cases, scope is not permissible into the publication. So things, for example, a paper that would be focusing on a scientific discovery. So a discovery that is created from using these new methods, that might take a back seat, or alternatively, the discovery of older methods that are still very useful and functional today. Methods lacking novelty should not be a criterion for whether or not a paper can be published. And yet I've seen plenty of reviewers say this method is old, and they've used that as if that's an actual explanation for why a paper is not suitable. And what bothers me furthermore is that an editor did not just slap that hand down and be like, that is not a valid critique of a scientific publication. You are not doing your job as a reviewer. You need to be more serious about this in this regard. And so I think that either we've seen editors become too active in promoting a certain approach, or alternatively, they haven't been proactive enough in making sure that the reviewers are actually rigorous and actually being good scientific thinkers. And so that's problematic. And getting back to the final point that I said that we'd eventually work our way back to, about making a point that you aren't acting this way. In science we say, I'm not saying in science we say that's silly, but there's the issue that we should not believe statements that are not sufficiently warranted, that have not been supported. And so the idea is that, it's always on the person making the statement to support it. And that's fine. So if I wish to criticize or critique the editorial or the review process of publications, obviously it is on me to provide evidence that that is going awry in some way. But I would say similarly, if you're in an editorial role, you cannot just, blithely say, oh, there is no corruption of the editorial or review process. That is also a statement that must be validated, that must be supported, and you should be doing that proactively. And I would like to see people in important institutional roles. Obviously, publications are just one institution of many in science. But people in these institutional roles should be proactively providing case studies that they are essentially trying to be honest in the review process, in the publication process, in what type of scientific inquiry is allowed. And it shouldn't just be taken for granted that, oh, if you want to critique these scientific institutions or these publication institutions, that it's entirely on the criticizer to do that job. If you want to state that these things are honest and open and versatile and lively scientific endeavors, then people do need to be saying, and here's the evidence for why we are keeping this thing alive and fresh. So that was pretty long, but Deborah, I'll let you follow up.
Well, I just wonder if, who could try to enforce that kind of thing, that maybe the associations involved should be trying to ensure that. I mean, I have often said about the American Statistical Association that they should see themselves as heralding diverse views and rival views, and that it's a home for people to discuss rival views as opposed to supporting one view rather than the other. And that has not happened. But so I don't know, maybe the associations need to step up to the plate and see themselves as really bending over backwards to make sure that all of the memberships and their conceptions are heard, and that it doesn't become a sort of political groundswell that if you don't follow us, you're not going to get published. There's one thing I wanted to mention, though, that we didn't consider. It's really been bothering me, and it comes up a lot with the COVID research that I have. We all know that people are talking about things that they're inexpert about these days because, of course, it depends. I mean, our life depends on these things and are threatened by some of the treatments and decisions and policies that are being made. But I have found that some of the experts are afraid to speak up. And they will write, I have had written exchanges with them, and they say, but I don't really want to say this. And so it might have to do, for example, with the different vaccines, whether there should be a certain time lag between the vaccines, the variants, and how they're being produced with certain patients. And they say, well, I'd rather not say, even though they have disclaimers with anything they say, well, my employer is not involved, but they still are very reluctant because it goes against, I guess, what the official line is of that university or company or whatever. So I see this as, and I'm glad that you're interested in this whole science, good science, bad science concern. And that's a kind of hidden one, maybe, that is precluding good science.
Yeah, I mean, to be honest, I'm not sure if it's actually that hidden versus it's just simply not publicized, because the fact is, in a large number of private conversations between scientists, there's a large number of people saying, like, having completely legitimate scientific discussions and concerns. The types of conversations that happen, in the lunch halls at Oxford, where one of these vaccines was actually developed, and the types of rigorous conversation that has defined these types of institutions and has been completely okay to have for any other topic, but people and continues to happen when people are sort of off camera or just having their virtual lunches with colleagues and things like that. And there's a lot of rigorous conversation and critique that might not even actually change the course of things, but at least, like, there's robust criticism and conversation around some topics that people are afraid to have because they don't, either they're worried that they're coming to some unallowed conclusion. But the alternative is that and maybe this just comes back to weaponizing methods. People are afraid that, like, their basic use of scientific critique and just scientific consideration, even if it's conjecture, might be weaponized in some way that they don't anticipate. So their description of, like, comparing, here's a completely legitimate scientific discussion, which immunological mechanism do we really want to be entrusting to help inoculate our population against COVID-19. And obviously, we have a number of options there. And the question is like, which vaccines will have which effects for good effects for short term versus long term? Which are our best chances for a long term vaccine? And obviously, now the question is, do we even have a chance at a long term vaccine, or will it become something different that we're all always having to update? And those are interesting scientific conversations, and not all of them even actually involve statistics. They could just be talking about the actual biological mechanisms that we know to be true. For example, like biological mechanisms of the adenovirus. It does seem like some of those rigorous, interesting conversations, which frankly are the most interesting conversations that people have in science, have been pushed to the side because it needs to be conclusion-based, and people are just wanting top-down, conclusion-based reporting and nothing else in the background.
I just want to say that a related concern that is really bothering me a lot these days is this idea of trying to come up with claims that will result in the most fruitful behavior as opposed to honest scientific answer. And we're seeing this from all of our representatives, the health from Fauci on down, that in answering questions, let's say, about what level do we need for herd immunity, he even admits that he's motivated to some degree by what will nudge people, let's say, to take the vaccine. And the new head of CDC pretty much said the same kind of thing with respect to masks. Should we be using masks with smaller particulate ability? She says, well, no. Why? Wouldn't that be more conducive to stopping transmission? Instead of answering that, she says, well, if I say we should use a stricter mask like an N95, a lot of people won't wear masks at all. So it's sort of calculated to whatever is most conducive to behavior that they want, as opposed to answering the scientific question. And to me, that's another way that you've got bad science. And even if we agree that on the behavior, it's still distorting the scientific question. So you can't really trust that you're going to get a full scientific answer, an honest one, because you have to think in terms of what it's calculated, what behavior it's calculated to produce.
Yeah, that actually, I've been similarly bothered by issues where essentially people are trying to sort of trajectorize. That's not a verb, but they sort of estimate the trajectory caused by their announcement or opinion. And they're trying to essentially, I guess triangulate would be a better word. They're trying to triangulate what they say in order to produce the effect that they want. And, there's several problems. That one, it will ultimately create a mistrust that people can't just say what are the facts and allow people to react to them in a sensible way. And the other thing, and I think that's just extremely basic, is the fact that you don't know how people are going to react to these things. But I can tell you how people will react once they stop believing you at all. And there is this issue. It's like, even if you are a scientist, are you an expert in how a population of, 9 billion people are going to react to something, or 30 billion people, or 300 million people for, I guess, the US population, or alternatively, 1/2 of the US population, depending on if something gets politicized or not. And so the idea is that I don't like the idea of people trying to triangulate. One, because you are moving away from just honest scientific reporting, which then obviously is no good to science. And two, because you're probably not even good for it in the short term. So the idea is you will be creating a long-term disincentive or long-term mistrust of science or of scientific discussion, while also not actually guaranteeing that you'll get any of the short-term benefit to which you aspire. And so I think that issue is something that people should be talking about more. And there have been plenty of cases, where people that at least come out and said, yeah, I totally said X, Y, or Z simply because I wanted to create effects X prime, Y prime, or Z prime. And, it just, I don't think that those things are what we need. Actually relates back.
Yeah. It's interesting how much some of these other issues really go back to that kind of gambit. So, for example, you might say, don't use the word significance thinking that it's going to prevent people from abusing the term and saying it when they are likely to be interpreted as meaning scientific significance, and thinking, well, if we don't have a specific cutoff for a p-value, maybe people won't data dredge. In other words, you think you're getting a better behavior out of it. In fact, people still, the researchers still going to want to show some real effect. And if the p-value is large, they can't say have evidence to that effect, because what they're saying in effect is that the probability is high that I get an even larger difference if it was chance alone. In other words, I'm saying that you might think you're going to get better behavior this way, but in fact you won't, but it will make it harder to hold people accountable if they're allowed to change, their woolly p-value or not have any standards for determining error probabilities. It won't improve things. But at the same time, you are sort of distorting. You're not being frank about the rationale for what you're saying in an analogous way to what we just mentioned about herd immunity or masks or whatever.
Yeah, no, I think that is a good point. I had an add-on, but now it has fallen from my head. But yeah, no, I think that is a worthwhile point. Cool. Actually, I guess it a bit reminded me of there's actually a conversation that I had earlier with Kevin Zollman at Carnegie Mellon, and oddly enough, it seemed odd enough to me until I did some back research on it, but it was on W.B. Du Bois and his work on the sort of the objective aspirations of science, and how science should aspire to maintain this objective goal, because the moment that you start essentially triangulating science to achieve a certain goal, you'll long-term undercut your own ability. So I found that interesting, that essentially someone who was, I guess we're now coming on a century past a lot of his writings, that, there's some good thinkers who called out these types of problems. And it would be, I think it'd be foolish to ignore the value in what they said.
Well, I hope that your series will encourage philosophers and others to go back to the whole demarcation problem. Even though we don't want to be doing necessary and sufficient conditions, we do want to be characterizing good and bad science, a good and bad method, good and bad inquiries. Even if you have a claim that is true, it's 100%, confident in it, it can still be poorly tested, and it doesn't indict the entire field, but just this particular study. We can say, well, we have much better studies of that. This one turned out to be poor. And it's a very important thing to discriminate. It shouldn't just be left to committees now who rule on whether so-and-so is guilty of fraud or plagiarism or changing the data. These secret committees that now exist to decide whether somebody ought to be stripped of their degrees. So I'm glad that you're doing.
Yeah, one of the main takeaways, and maybe there's a better conclusion than the one that I'm coming to, but the idea is that even if, for example, the necessary and sufficient criteria don't exist, which I pretty much suspect that they don't, or alternatively that our minds are too confined and low dimensional to be able to possibly create such criteria, that I think that going through the critical reasoning process behind it is what we can really get the value out of. And going through the process and sort of understanding, for example, boundaries. So like essentially what are the extremes and what doesn't work there. And then we realize that there's this more sort of challenging subjective section in the middle, and that's where we need to focus our work. It actually reminds me a little bit of, I believe you brought up the fallacy of the beard or the fallacy of the pile previously, where the idea was that even though that there is essentially a fuzzy zone by which it's hard to distinguish certain edge cases, it doesn't mean that there isn't a definite delineation between, or it doesn't mean that there's not a difference between things like bad science and good science, or pseudoscience and good science, and things like that.
But notice I have given 2 criteria which I consider necessary.
Yeah.
If your account allows claims, even though nothing has been done to find them false, I'll say that's not a scientific inquiry. And if your inquiry has no way to pinpoint blame for failed anomalies, I say that it's not science, or it's veering into questionable science. And it's interesting, this came up yesterday in talking about climate science, because somebody who's defending it was saying, but of course we can't pinpoint the sources for any disagreements. And I say, well, how can you actually accept that at the same time as you're answering the skeptics? And I don't think you can. So those are 2 necessary conditions. And with respect to sufficiency, that we're interested in science and broadly in finding things out and in making progress and finding things out, usually with some sort of empirical and theoretical background. But it's not necessary to flesh that sufficiency out entirely in order to avoid what we care to avoid, and that is bad science or questionable science.
Yeah, actually, that's a good point that I had not quite considered. That the idea that there might be a difference between whether or not what we need that's necessary versus what we need being sufficient, and the idea that I guess maybe I'm misinterpreting this, but the idea that the sufficiency issue seems like it might be harder to achieve. Maybe even it's not worth saying, just because the idea that the sufficiency means that I guess there's a harder bound on what we would accept as science and well-vetted science and things like that, where the necessary element, I think, does allow us to start putting up building blocks for what we do need. So I think that is I appreciate that you made the distinction that
because the other, sorry, I'm sorry.
Oh yeah, go ahead. Yeah.
I was just going to say, because the other aspects aren't really that problematic. Should we call, cooking a science, home economics, is that a science, economic science, and these things, that's not harming anyone. Insofar as a certain portion involves inquiry and finding things out, and if you do put them to the test and satisfy these necessary criteria, then I don't see any harm in calling it science. You're not getting into any danger.
Yeah, that is a good point. And I guess we'll wrap up soon, because I know that we're running low on our Deborah time. But one bit that popped in my head that's maybe a few topics back was the issue that it's unfortunate that in publications, for example, you can't be listing the shortcomings or the flaws or improvements to this testing, how severely you want to test your claims, because there's a fear that essentially an obnoxious reviewer is going to take that and uses that against you to prevent you from publishing. I think that is something that is it's something that we need in the literature, where people are enumerating the various issues and the challenges and the critiques of their own methods in ways that they could move forward, in places where they might say, I believe this claim to be true. However, there are stronger ways to vet this claim than what I've done here. But at the same time, please publish me so that I can keep my job and keep feeding my children and things like that. And so I think that there is an issue where people should not be essentially, we should not be penalizing researchers for describing the bounds of their claims. And unfortunately, the current review system does.
You're saying that they shouldn't be punished for admitting that they didn't probe well because they simply couldn't? There are
a number of ways that you could essentially be prevented from doing these things. The current state of the data might, as you said, there might be a better data set by which to probe a certain set of data, by which to probe some claims. Clinical data, there's a large number of confounding issues that, yes, we'd like to have data on to more fully vet this. But one, we don't have a mathematical formalism or a model formalism to do that. And two, if it doesn't exist, we can't vet it as well. And so there are confounding issues there. And to move the scientific knowledge forward, we should be looking in those ways. At the same time, generally, you might have actually come to the correct conclusion of, for example, a therapeutic effect while still not having accounted for these other confounding challenges?
Well, I think describing the um, constraints and the limitations of your own research is standard and is extremely important. And should also describe when you get negative results, because it could actually be very positive in the sense of finding a lot out, that you should be prepared to say what you have found out. On the other hand, I'm rather strict in this other way. I think that if you have a field that is continually uh, having to resort to questionable research practices in order to say that we have effects, that there comes a time that you want to question the whole field and all of the measurement uh, assumptions. There's certainly some areas in psychology where it's questionable that you're really measuring what you purport to. And I say that we should be prepared to, in some cases, falsify measurements and falsify types of inquiry. That, in fact, that's not a good way to inquire, and that we should try to build accounts of good inquiry in ways that we have gotten around threats to reliability in certain fields, and maybe by a particular type of error or mistake that we have learned to circumvent, that we can build up a kind of what I call a repertoire of errors that way. So I'm prepared to say that we shouldn't just excuse the whole field, as I see some people do, and say there's just no way they can publish if they're not allowed these unscientific, questionable research practices. And I say, well, that really does indict the field in that case. Maybe they shouldn't be collecting data. Maybe they should be theorizing or doing field studies and not doing statistics.
Yeah,
so that's maybe radical. Yeah.
Oh, I mean, I like that. Where if there is a sufficient, if there are certain like severe indictments to the how critical or like how rigorous the scientific methods are, then why would that not be a signal to the field that perhaps instead of focusing on what you're currently focusing on, perhaps you ought to be focusing on other aspects and addressing those aspects first. So there are many ways in which you can advance a field. As statisticians, one of the ways that we like to think about is you advance it by developing new statistical methods. But the fact is, if there's something that's really preventing you from making strong scientific claims about a field, then that's a very strong signal that you should be focusing on those issues. And that's where it's important, as opposed to doing the sort of easier work of publishing issues that are dependent on flaws, like if publishing phenomena or publishing conclusions that are based on flaws. And it's like there's no reason why a scientific field can't pivot to start addressing its weaknesses. Everyone else sort of has to pivot and do things to start addressing those weaknesses. It's like if you're rowing a boat and there's a hole in the boat, you can't just say, well, that's a problem, but my job is to row. Right. It's like, well, no, you're now actually going to be a hole patcher, and you need to patch that hole before you get to row again. Do you have time for one final question before we go?
Okay, sure.
Yeah. It was on the issue of falsification, because one thing that I've found helpful is, at least, I tend to think of in my framework of, medical machine learning, where the idea is that we're using algorithms to separate some amount of signal from noise and provide some type of useful information to somebody, either a clinician, a clinical care practitioner, something like that, with information by which they'll do something. And one of the things I've really tried to focus on is there are a large number of effectively ways that I think are unhelpful. For example, predictive methods that I think would fail in a certain setting. And so one thing that I've been trying to do, just sort of as a side exercise, is figuring out, it's like, okay, can we actually falsify? Can we figure out why deductively certain methods are just extremely unlikely to work given a certain set of data and certain set of goals from that data? And what I like about that is that it can save a large number of people like me time. It prevents them from literally just marching off, having never thought about the assumptions, the nature of the data, the nature of their algorithms. And it prevents them from just wasting a whole bunch of time that way. At the same time, obviously, I don't like the certainty that it entails in my own deductive abilities. And so I guess, obviously, this is a broad question, but do you have any thoughts on the issue of deductively concluding that certain methods are just not good for certain applications and using that as to help build up what we do consider to be good practices?
I want to say, first of all, that I don't think that any interesting falsification is going to be deductive, even though we might try to reformulate it that way. By and large, what we have to do is infer inductively some hypothesis that is then going to contradict some claim, what Popper calls a falsifying hypothesis. So in other words, you need to infer some sort of generalization. Even in your example, where what we're inferring is this is never going to work for measuring people's intrinsic self-worth or some concept like that. Okay, so I just wanted to clarify that part. And yes, I think that people should study that and be able to say why there's always going to be these loopholes to the extent that there are legitimate ways to explain away any anomalies. Remember that idea about normal science as the part of it that I think is right is that you really need to pinpoint the sources of mistakes, and it's not enough just to have criticism. Kuhn distinguishes astronomy and from crystal gazing or something, because the astronomer can correct when things go wrong, and the astrologer, the crystal gazer, can critique each other. There are rival schools of astrology, but it's not constrained by what is actually the case. So my point is, I think that you can show, and that it'd be valuable to show, that some areas are never going to have that constraint. Is that the kind of thing that you had in mind, that you would be able to actually falsify the possibility of using this measurement for something that you had hoped? Because it's not really a measurement of what you want at all.
Yeah, I think that's actually one of the issues. So I have, in some regard, attempted to, and I obviously, like, deductive falsification isn't quite the right thing, because obviously I work in an applied field. Many of my assumptions are based on evidence in some way. So effectively, I am taking a set of data, proposing that it has this general, there's this general truth to it, and then taking the conclusion from that data and saying, now, assuming that this is true, then these other issues fall out. And I have actually fiddled with, so the insufficiency of certain metrics. It's a work in progress that I've been trying to do, and sort of, at the very least, I hope it adds a bit more sensibility to my little neck of the woods, where people can. So I guess my general thing is, like, I've gotten pretty good at figuring out why certain analysis pathways will not lead to the useful results that we want, and now I'm trying to formalize that so that I can help other people use it too. And so obviously, it's definitely a work in progress. I do like your distinction, because obviously it's not a purely deductive aspect. Like, it is not even remotely a purely deductive aspect. There are certain strong induction aspects to it, but I do appreciate that point, and now I've a little bit lost my train of thought. But
I'd be interested to read this. I don't know if you have something written on it.
I could. Yeah, and I guess a friendly critique would be appreciated, because obviously, we'll see where it goes, what works, what doesn't work, and I'll pass that along. It's actually and actually it's something that the listeners will be able to listen to soon. It's associated with me being recently put on an editorial board of a journal, and I'm writing about some of the sort of critical thinking mechanisms in data science. So I would actually very much appreciate some feedback on that, and if I'm even describing the words correctly.
Great.
Cool. Well, there you go. One of the best reasons to host a podcast is that people will volunteer to read your work and provide helpful feedback. So, Deborah, again, thanks so much for your time today. I appreciate it.
Thank you so much for inviting me and for doing this all together.
Hey guys, it's Glenn. Thanks for your time today. I hope you liked today's episode. If you did, please consider smashing that like button. It's the single, simplest, fastest way to make sure that YouTube shows this video to more people. If you really want to go crazy, consider subscribing or going to our website and joining the mail list. If you want to go totally crazy beyond that, forward this to a friend or colleague who you think might enjoy this too. We're a small channel and every bit helps. Our next episode will be coming out next week, so in the meantime, feel free to look around the channel and see other videos that might be of interest. As a quick disclaimer, the views expressed in the show do not represent anything other than the people saying those words, views, etc. like that. It doesn't mean anything about their employers or their employers' views or some thing about their employers or their neighbor's cat or anyone else not saying the words. And in fact, given that people tend to change their views when they're thoughtful enough, it might not even represent the views of the speaker by the time you're hearing the episode. So definitely come back and see if they've changed their views at a later date. They also don't represent the views of our sponsors. Thank you to our sponsors. You can check them out on our website.